So we have talked about climate mitigation, and without explicitly saying it, we are often looking at the supply side of things: energy supply, transportation options, food supply, agricultural emissions, and how to mitigate them. And we have talked a little about dietary choices and choices of transportation without saying whether they are individual choices or they are kind of demand side solutions. So there's a series of papers by a group that looks at demand. Why am I having trouble saying demand? Demand side solutions that can add significantly to climate mitigation. So includes a lot of jargon and economic aspects that obviously I'm not an expert on, but I want to raise a few points using a couple of three papers in two podcasts, starting with this one, which was a review but back in 2016, and there are more papers from the same group last year that I will use in the next podcast. So obviously there are exogenous and endogenous kind of preferences, which intuitively you know what it means: external factors influencing your preference versus internal factors. Economic modeling makes it slightly different in terms of variables they have to use that are defined as exogenous or endogenous. So here things like how you feel about protecting the environment, what your religion says about whether you should be the steward of the environment or it's God's job to protect the environment, and so on. So those, altruism for example, those kinds of things can influence your choices. And always the big question is whether does a demand for something mean it is associated with a sense of well-being. That's more complicated and relates to behavior. So demand side solutions have to include some behavioral change. For example, Steve Jobs is known to have said that people don't know what they want, you have to show them. So he showed people with the iPhone that this is a cool stuff, and everybody wants an iPhone, and they line up to buy the latest version every time it comes out. Does that mean it's associated with well-being, or is there some external extrinsic image factor or convenience, comfort, whatever it is, right? So those things get a bit complicated, but demand side solutions can also be thought of in terms of sectors, and then options for mitigation and how they impact greenhouse gas emissions, because obviously demand side solution for mitigation means they have to reduce emissions. So here are four characteristics of urban form that affect transport emissions and associated elasticity in distance traveled. So already we are jumping into a urban setting with transportation sector. Relevant metrics to measure covariance with density and visualization of greenhouse gas emission ranges, which is a modified figure from an IPCC report, earlier IPCC report, 2014 one. So you're looking at density, land use, connectivity, and accessibility as four characteristics of the urban form that people use to decide on transportation options. Vehicle kilometer traveled in the US, it's usually referred to as vehicle miles traveled. So the elasticities in them means a supply side option will change the demand side behavior. Under density you have population and job, residential, household, job, and population. And under metrics to measure you have household per population, building and floor area ratio, job, commercial, block, parcel, dwelling unit, and obviously the density with covariance is 1 for density. And you have induced greenhouse gas emissions that can be high or low depending on how the density changes. So low density will produce high greenhouse gas emissions, low density will produce high density will produce low greenhouse gas emissions for you're thinking of residential, industrial, commercial, and so on. So similarly, under land use, you have diversity and entropy index, a land use mix. So job mix, job housing balance, job population balance, retail store count, working opportunities. So mixed neighborhoods, convenience, access, etc., which is here. Connectivity, so combined design metrics, intersection density, which looks at these kind of maps here. So this is a low intersection density, high intersection density. So proportion of quadrilateral blocks, sidewalk dimension, street density. So lots of nice details. Correlations here, land use is not correlated to density, independently decided. So you can end up with high and low emissions. Here, density has a significant correlation with connectivity, but accessibility can have very low correlation with density, which includes regional accessibility, distance to central business district, job access by automobiles, job access by public transportation, road induced access, and so on. So again, you have various ways in which you can reduce induced greenhouse gas emissions. So looking at the economic potentials of supply side options to reduce greenhouse gas emissions in the agricultural sector, depending on the carbon price for 2030, compared with the technical potential related to demand side options for 2050. We will see on the next slide where such a large technical potential for the demand side carbon price will come from. So here is greenhouse gas reduction potential in gigaton CO2 equivalent per year. You remember we convert non-CO2 greenhouse gases to CO2 equivalents using global warming potential. So supply side carbon pricing, US dollars per ton of CO2 equivalent. If it's less than 20, less than 50, less than 100, so you can have with increased prices higher reduction potential, but at some threshold you might end up with a low potential as well. On the demand side, it's envisioned as having a technical potential on the low side, that's on this range here, and high side, which is much higher than anything we could accomplish with these kind of carbon pricing. Why? Because if you look at climate change mitigation options and their quantitative reduction potential, end-use sectors being urban areas and spatial planning, transportation, tourism, buildings, and agriculture and other land use. Mitigation options, I won't go through the entire table, but each one is got an estimated reduction potential for greenhouse gas emissions, and the corresponding studies are cited in this paper as well. So, for example, in urban areas and spatial planning, we have modifying the emerging urbanization with 20 to 25% reduction of future urban energy use until 2050. Under transportation, optimal pricing, compactness, behavioral measures like marketing, information provision, and tailored services. Tourism, buildings have a lot of options, developed context, short-term behavioral change potential, long-term behavioral change potential, 50%, which is quite nice. Continuing in buildings, developing context, so behavioral change is there as a relevant potential, but lower. Heating, cooling, clothes washing and drying behavior, large range here. Water heating and cooking energy savings, lighting energy savings, refrigerator energy savings, dishwasher energy savings by full load operation at 75%. So a lot of these are again going to preferences that can be hopefully modified. Then human mind can internalize the norms, so we can look at some of the norms. Agricultural and other land use has technical potential of demand side options for 2050 at 70%, and healthy diets, which we have discussed before, 90 gram per person per day of these total things, meat, fish, and egg consumption, with a 36% greenhouse gas savings. Obviously, it's not clear how we would accomplish this, but it's good to have a sense of the potential for mitigation with demand side solutions. So as an example, low carbon urban development scenario would save approximately 190 exajoules in the annual direct final energy use of cities, including electricity consumption and heating in buildings and energy use from urban transport compared to business as usual scenarios. So different regions are looked at and the evolution of energy use over time, historically and out to 2030 and 2050. So Asia has an increasingly large potential for reducing direct energy use consumption compared to business as usual. Similarly, Middle East and Africa, Organization of Economically Cooperating and Cooperation and Development is here. The countries under reform, and then Latin American and Caribbean countries. So you can see that there is a substantial potential for reduction of 190 exajoules by 2050. Comparing behavioral and rational choice approaches, assessing mitigation solutions from a behavioral perspective implies taking a rich contextual perspective. So what are the contexts in which behavioral choices and preferences happen, and what are the options or pathways to making behavioral changes? So comprehensive model of human behavior looks at contextual modifiers and rational choices. So some context is provided, let's say, by infrastructure, or there is a cultural context like altruism, morality about environmental stewardship, ethical behavior, climate justice, all sorts of things can come in, and social norms and motives, why somebody would want to drive, why somebody would want to ride a bicycle, shared rides, and so on. And that can map onto preferences, beliefs, and decision making. So finally, looking at normative positions and their influence on shaping policy decisions, as an example in transportation related choices. So what are the transportation related factors? Environmental awareness, mode choice, safety, commuting, car purchase, and infrastructure. If you live in some parts of DC, for example, if housing is unaffordable and you want to live in the suburbs and come in to work, is the public transportation good enough? What are the options in terms of commuting time it takes versus when you can come in and reduce the commute time, and so on. So people make lots of choices without necessarily worrying about greenhouse gas emissions, but just a sense of well-being, which is very subjective. Okay, and that depends on whether you are a liberal or not. In other words, there's an old joke about how whether you can be that you can be happy or married. Similarly, there is an article that says, do you want to be happy or liberal? Right? So as a liberal, do you worry about more things? Let's not get into controversial arguments, but subjective well-being includes things like rewards for individual altruistic behavior, incentives for non-motorized transport, change in social norms, and cues against biases. Disincentives, safety-wise, disincentives for risky behavior is subjective well-being. Commuting, disincentives, car purchase, vehicle tax can be a subjective well-being, and infrastructure-wise, subjective well-being depends on prioritization, non-motorized transport, and short commutes. Liberalism, the way people make choices itself can affect the transport-related choices. So no particular rewards in environmental awareness, mode choices, degree of incentivizing non-motorized transports depend on types of liberalism. So we won't go there, but you can read up. Safety, no disincentives for risky behavior. commuting, no disincentives, car purchase, a status tax according to type of liberalism. So, for example, will you buy a very expensive electric vehicle because you are paying for your sense of environmental awareness and you can afford it, and it's a status tax of some sort. I'm just kind of giving you a vague metaphor, but nonetheless, under infrastructure, it's not directly applicable, but alternatively, elicit preferences in simplest context. Okay, so this gives you a sense that demand side mitigation has sectoral options with substantial technical potential without worrying about exactly how we would accomplish. It's obviously very important to consider these. So we'll come back and see if demand side solutions can be designed to a lifestyle of high well-being, remembering that well-being can be very subjective. Okay, so we'll do that in the next podcast.